Okay, so today I will discuss uh, previous year questions on linear algebra. Okay, so here you can see that the question is given that if A is an here it is given that if A is an uh, A from Rm to Rn be a non-zero linear transformation, then they are saying that which of the following statements are true. Okay, so now as we know that uh, from rank nullity theorem, what we know that if A from Rm to Rn be a linear transformation, right? A from Rm to Rn be a linear transformation. So what we can write that by rank nullity theorem we can write that rank of A plus nullity of A is equal to dimension of V, since Rm over R both over R, so Rm over R dimension is M, right? So this will be how much? M. So now if A is 1 1, that means what? When a linear transformation is 1 1, that means that nullity of A should be 0. If A is 1 1, so nullity of A should be 0. That means what? Now rank of A is equal to M. Now as we know that if A from Rm to Rn be a linear transformation, so rank of A, that means dimension of the range space. This is also a subspace of Rn, so this should be less equals to n, right? So this implies that m should be less equals to n, but in option 1 it is given that m is strictly greater than n, so this option will be incorrect. Okay, now it is saying second option, what it is saying that if A is on 2 but not 1 1, then m should be less than n. Now if A is on 2, that means it should be of full rank, right? So rank of A is equal to n that time. So if rank of A is equal to n, then what will be the, but not 1 1 that is saying, so what will be your nullity of A? So in that case, if A is on 2 but not 1 1, that means what? Now nullity in that time, nullity of A will be strictly greater equals to 1, right? It cannot be 0. So now nullity of A will be how much? M minus n will be greater equals to 1. So I can write that m is strictly greater equals to 1 plus n. But here it is saying that m is strictly less than n. So this option also incorrect, right? Now goes into post option number 4, right? Here what is it is saying that A is 1 1, then m is equal to n. ये क्या necessary होगा? मतलब if I can say that suppose your m is equal to something like 3 or 2, whatever you can take, like suppose it is a linear transformation from R3 to R2 or R you can write. So by given by suppose A of whatever x sorry x y z, it will be suppose x, right? So it is clearly 1 1 because x is distinct here. But here you can say that m is equal to 3 and n is equal to 1. So m not is equal to n, correct? So if A is 1 1 but m not is equal to n, so definitely our option 3 will be the correct option. But how can we prove that if A is bijective means what? Bijective means A should be both 1 1 and on 2. A should be both 1 1 and on 2. Now since A is 1 1, that means what? That means your nullity of A is equal to 0, right? Or null space, it will contain only theta. So here it is the here rank of A will be how much? Rank of A will be, now as we know that rank of A plus nullity of A, that means rank of A plus nullity of A is equal to dimension of the domain space, that it will be M. Now since it is 1 1, so that means nullity of A is equal to 0. That means what? The rank of A will be equals to M, and as we know that rank of A is strictly less equals to N, so we can write that M less equals to N. Now in second case, since A is on 2, that means rank is the rank should be equals to N, right? Yes. So now what we can write? So your since rank is equal to N, so here you can say that N also less equals to M. Since rank of A plus nullity of A is equal to M, so N is also less equals to M in another case. So both combinedly you can get that M is equal to N. So your third option will be the correct one. Okay. Next goes into the next question. Now what is the next question, as we have seen that? This question is also from the topic of linear transformation, right? So here what it is saying, okay, now see, it is saying that A is an 10 cross 10 real matrix and rank of A is equal to 7. Then which one of the following statements are necessarily true, right? So since we know that A is an 10 cross 10 real matrix in that case, and that means entries are coming from the real field, and rank of A is equal to 7, right? So which one of the following statements are true? Uh, okay, now comes into option number 4. A to the power 7 is equal to 0. Okay, now since rank of A is equal to 7, as we know, rank of A means what? Rank of A means we can say that number of linearly independent rows or number of linearly independent columns. Number of linearly independent columns. Now, since here in the option is A to the power 7 is equal to 0, so we can assume A in terms of something like nilpotent matrix, right? But here it is saying that rank of A is equal to 7. So does it possible that A to the power 7 is always 0? So if you construct in that way, like suppose, okay, since rank of A is equal to 7, so first you take a 7 cross 7 identity matrix. So identity matrix will be like 7 cross 7. So everything in the diagonal will be 1 and rest other are 0, right? Rest all other elements are taken as 0. So this would be definitely it will be 3 cross 3. Here also it will be 3 cross 3 matrix. Okay. So this is a 7 cross 7 matrix. So definitely I can say that if it is an identity of order 7, so A to the power 7 cannot be 0. So that means this option is not correct. Now A must have a non-zero eigenvalue. Now, okay, since rank of A is equal to 7, if we consider A as a nilpotent matrix, that means what? All eigenvalues are 0, right? In the diagonal. Now, if you take that 7, that means in super diagonal, like total 7 ones should be there, right? So that means in that case, there will be a block of order 7, correct? So that means in the if you take that your a minimal polynomial of x is equal to x to the power 7, something like that, and your characteristic polynomial of a is equal to x to the power 10. Okay, a is a nilpotent matrix, so in that case definitely your rank of a will be 7, because a already have a 7 order, like minimal polynomial is x to the power 7, so definitely a has a 7 order, like 0, all the diagonal elements are 0, that means a block of order 7. So a must have a non-zero eigenvalue, that is also not always true. Now comes into option number 1. There exists a vector v belongs to R10 such that ab not is equal to 0 but a square v is equal to 0. So here something comes into the picture, that like as we know that mm, AB is equal to 0 means what? V belongs to like kernel of a, this type of things is happening here. So okay. Now okay. So now say if there exists, if suppose there does not exist any vector, or there exists no vector v belongs to R10 such that your AV not is equal to 0 and a square v is equals to 0. Okay. Now if a square there exists, if suppose for all vector, if a square v equals to 0 for all v, then what will happen? Then definitely a square will be a null matrix, otherwise it cannot be 0, right? So if a square is a null matrix, that means what? As we know that minimal polynomial is the least degree annihilating polynomial which divides the characteristic polynomial. So minimal polynomial of a, you can write that divides x squared. So this will be either x or x squared. Now since minimal polynomial of, if minimal polynomial of a is equal to x, that means what? Or a square is equal to, or yes, minimal polynomial of a equals to x means what? A should be identically 0. But if a is identically 0, then rank of a cannot be equals to 7, right? So this one is also a contradiction. This cannot be happened. Now, if minimal polynomial of a, if minimal polynomial of a is equal to x squared, that means what? There must exist maximum order block corresponding to the eigenvalue 0 is 2, right? So since A is a 10 cross 10 matrix, means how can you construct? And here it is given that rank of A is equal to 7. So if you construct in that way, 0 1 0 0 0 1 0 0, in that case like 2 cross 2 matrix, so there will be 5 2 cross 2 matrix in the principal diagonal, right? All are 2 cross 2. So in that case, your total number of 1 should be 5. So rank of A, all are linearly independent, all rows are linearly independent. So definitely rank of A cannot exceed 5. And in another case, it will be all 0. So definitely rank of A will be less equals to 5. So in that case also there is a contradiction. So minimal polynomial of A cannot be equals to x squared. So that means what? That our assumption that a square v naught is equal to 0 for all v, that is not correct. So definitely there exists, so we can say that there exists some non-zero v such that a square v is also not equals to 0. So in that option you can say that there exists a vector v belongs to R10 such that a square v not equals to 0. This will be a correct one. And in that case also, so such that ab not equals to 0 but a square v equals to 0, so this is also wrong. So this will be the thing. Thank you.